problem on projection of plane, and the plane was pentagonal plane. Okay, so we have discussed both the methods. First one is the change of position method, and second one is auxiliary method. Okay, you are aware with that. Okay, so now I will take you today through few different cases and the different kind of planes. Okay, so first of all, here you will see, if you look at the screen, you will find that this problem is on the rectangular plane, right? I hope my screen is visible to you. Is it visible?
Yes, sir.
Yes, sir.
So now see, read the problem statement. A rectangular plane of 60 millimeter by 40 millimeter size is resting on HP on its smaller side. Draw the projections of plane when its surface is inclined. Its surface is inclined. Just a minute. Okay. Surface is inclined to HP at an angle of 45 degree, and resting side is inclined at an angle of 30 degree with VP. Okay. You just spend a minute time in reading this problem, understanding the statement or the conditions given. Okay, then I will explain the steps. Okay, so you just try to understand the problem statement first. Okay. Yeah. So according to this problem statement, rectangular plane is resting on HP on its smaller side. It means, and resting on HP itself. Okay, means your top view, that true top view, will be on HP, and that will be, of course, below XY line. Okay, so suppose here at any distance from here, you mark the first point. Okay, you mark the first point, and then you complete the rectangle considering 40 millimeter side on left side. Okay, 40 millimeter side on its left side. Okay, and then complete this rectangle. Okay, then immediately name this point A, B, C, D, and then you project it so that you will get the front view. So take the projection from here, what straight lines from these points, and these points will give the 2 points on XY line. Okay, 2 points on the XY line. You draw the line again according to the point. You should mark the straight line, and you are going to get the straight line. Okay, you should draw the straight line from here. Okay, now You got this line on XY line, and that is nothing but your front view. Okay. As it is resting on HP, we complete the first stage with the assumption that the plane itself is on its surface lying on horizontal plane, so that only then and only then we will get the true shape. Okay, then you will get the front view as a line view here. Next, you have to make the surface inclined at an angle of 45 degree as per the given statement, right? Then what you have to do, you have to choose the point, any point here like this point, and then through this you have to take the 45 degree inclined line, and then you have to make it, you have to transfer this front view as a line view exactly of exact length, and that must be taken at an angle of 45 degree. Okay, right? Now you will see this A dash, B dash, and C dash, D dash length is nothing but the length of second stage here. A dash, B dash, C dash, and D dash at an angle of 45 degree. Okay. Then take the projections from A dash, B dash. Okay. Take the projections from A dash, B dash straight. You'll be going straight.
Sorry to disturb, but what's the distance between A dash, B dash to C dash, D dash?
A dash, B dash. Second stage. Are you talking about the second stage?
Yes, sir. Yes, sir.
So this is nothing but the distance of this front view as it is. You'll be taking here. Okay. Means we are going to make this rectangular plane inclined at an angle of 45 degree. Okay. Then what will happen? If you take this 45 degree, then this line view that is on XY line in first stage, that is going to be inclined at an angle of 45 degree, right?
Yes,
Understood?
sir. Yes, sir. Thank you.
Then next, you will be taking the projection from here. Again, the distance between C dash, D dash in first stage and A dash, B dash, any distance, you may take 10 millimeter, you may take 5 millimeter, you may take 20 millimeter, doesn't matter. Okay. Okay. Take the projection from A dash, B dash up downward. Then find out where is point A in first stage. This point is here, right? So on its projection, you will be taking the projection where it intersects, you will get the point. Similarly, B and C, I'm not going to draw the overlapping line because color is different. So B and C on the same plane, so I will be taking it from here. Okay, so I will get the A point and the B point. Similarly, take the projection from CD. Okay, just a random line you just draw, that will be the thin line, and again see, find out the C and D point in first stage top view. That C and D point, C is here and D point is here. Okay, take the projections further, extend it, it will going to give the C point, right? Okay, so in this way you will get the point. Then once you will get the point, you have to convert it into the thick line. So blue lines here, which I am drawing here, those lines are thick lines, remember. Okay, so this is what the rectangle you will see when you make it inclined at an angle of 45 degree to HP, right? So this will be the apparent top view, you can say, or the second stage top view, that will be. So have you noticed the change in the length of the sides? See, the length of side, which I will mention here. See, when you make the plane inclined, side A, B, and this AB remains same. Understood? The change happens to be in this longer edge, because longer edge is going to make inclination or that with surface by keeping this AB side remain perpendicular to VP. Okay, and it is not going to have any inclination with HP. Okay, so these sides that AD and second stage AD, it will be different. Okay, means this length is going to be the apparent length. This length AD will be the apparent length, and it will be less than the this AB line, AD line. Okay, so that is actually the 60, but next stage, second stage, you will get it less than 60, right? Now, third stage, resting side is mentioned, it is inclined at an angle of 30 degree with the VP. Okay, resting side is mentioned inclined at an angle of 30 degree with the vertical plane. Okay, so you can solve this problem by using two methods. Okay, and yeah, as you know, the first method is the change of position method, and second one which you have studied is the auxiliary method. Okay, so choice is yours. Any one method you can choose to complete your third stage. Okay, so I have already explained you earlier that how you can take the change of position method. I will just brief you here. In change of position method, you have to draw the line at an angle of 30 degree that is given here. So have a line from any point, again mark any point on XY line, and through that you have to draw the 30 degree inclined line, right? Once you complete the inclined line, you have to copy this top view as it is here. Okay, you will be going to copy it as it is, means AB line or that is the resting side is inclined, that is given here. So mark any point here as A, mark point, suppose A point here. Then once you mark one point here, do one thing, mark it second point here. Okay, and then join that point. Okay, and you will get the line. You will get the line from this point to this point. Okay, right? Then you will be taking the distance. This distance B to C. See, B to C line is perpendicular to AB line, right? To this AB line, it is perpendicular. So through B point, first of all, draw a line perpendicular to that one. Okay, and that is going to be the line perpendicular through B point, and it will be going like this. Okay, so any length is just first of all you have to take the line length. Suppose you will take the lines like this. Okay, then you have to have measurement of second stage BC distance. I will say BC distance first you take from here, then AD distance. So take these distances in compass, and through this mark the point. If it is cuts here, and at this point, it means it will give the another points, 2 points here. Okay, and through this you should draw the line through this and complete this third stage top view with change of position method. Okay, so in this way you will be going to just what you have done, you have just drawn this in new position as it is, copy and draw. Okay, all those dimensions you have to copy and you have to complete your answer. Okay, then next, as you know that points are here already, A, B, C, D. I'm not going to write those points here. Okay, now I will start taking the projections. From A point, I will be going up through A point. Okay, draw line through A point. So of course it's supposed to be exactly perpendicular to XY line. Okay. See, A point, A vertical projections, and the A point project here at this junction. You will be taking the projections where it intersect. It will give the point A, right? Similarly, take the projection from B vertically. Then B point is here. So from here only, you just continue with, and where it intersect, it will give the point B dash. Similarly, take the projection from C, go vertically. Okay. Then take the horizontal projection from second stage front view, that is C dash. Take the projections and it will be coming like this. Okay. Where it intersect, you will get the point C dash. Similarly, D point, you will be taking vertical. You will be going vertical, and projection from D, where it intersects, it will give the point D, right? Then finally, you join this with straight line passing, covering the CD point, C to B point, B to A point, and D to E point. Okay, means the D dash and A dash. All those points, once you join, you will get the final front view. This is nothing but the final front view. Okay. So this is with the change of position method. Now choice is yours, whether you are interested in change of position method or auxiliary plane method. Okay. If you are interested in auxiliary plane method, then how we can do it? You have to just extend the line which is given inclined. Which line is given inclined? Resting side is inclined at an angle of 30 degree. So which one is the resting side? This AB, right? AB is the resting side. So what I will do, I will extend this word AB line further. Okay. I will be extending it further. Okay. Then through any one point, I will mark the point, suppose at this junction. Okay. And then through this, I have to take the 30 degree. So to this line, I will be drawing line at an angle of 30 degree, right? So this 30 degree, sorry, I will be taking this 30 degree from any point here. So it might, you have to take it with the extension little, you can go further. Okay. So this line is nothing but the 30 degree inclined line. Okay. So this line is 30 degree inclined, right? This is what the inclination 30 degree. Okay. So you can see the 30 degree. Okay. This is what the 30 degree. Okay. Then you continue with as usual procedure in getting the further points. So how will you get the points? See, from each point through A, draw a line which is going to be perpendicular to this line. It should be perpendicular, right? It will be perpendicular. So suppose if I take it from B, I will take it perpendicular to this. So see, you have to make sure that this line is supposed to be perpendicular to XY line. Okay. It must be perpendicular. Okay. And this line, green color line, which you can say X1, Y1 line. We say it's a X1, Y1 line. Okay. Then take the distance of A dash and B dash, that is second stage front view, from XY line. If you consider it from the XY line, A and B points are on XY line. So obviously, when this projected black color line intersects here, obviously you are going to get the A point, then B point. Similarly, take the projection from C and D. Take the projection from C and D. Random length you just draw a line. Okay. Then have measurement of distance. You have to have measurement of distance. How much is the distance from XY line, that point of point C and D? So this is what the distance with the point from this point to this point is nothing but the distance, right? So this distance you have to take in a compass and you have to draw those marks on this black line here, and wherever you will get the points, finally you have to join all those points with thick line, okay, and complete that final stage front view, okay, without changing the position of second stage top view. Okay, you can directly get answer with auxiliary plane method. Okay, and this is going to be the final top view, right? So in this way you can complete the solution for this. Okay, then okay, now I will be taking to the next case. Okay, I will be taking to the next case. What's the next problem? Okay, so this is the problem on isosceles triangle having its base 40 millimeter and altitude 60 millimeter. Okay, altitude 60 millimeter is resting on HP on its base. Draw the projections of plane when its surface is inclined at an angle of 45 degree to HP, and base which is on HP is making an angle of 50 degree. So here, just for reference, I have drawn one isosceles triangle as a type of plane, for which I have given the dimensions 40 millimeter base and the 60 millimeter altitude. 60 millimeter altitude is nothing but the distance from this center to this one, right? So this distance is going to represent the altitude. This one is nothing but your base, and these are the remaining sides here. You will get the isosceles triangle. Okay. Now you have to think about the position defined in this problem statement with respect to HP and the VP and the inclinations. Okay. So it is mentioned that it is resting on HP. Okay. On its base. So of course, this side, if you name this as a AB, so AB is the side on which it is resting. So obviously, while getting the true shape in final stage, you have to take the resting side AB on left side, not this corner. You can't take this corner on left side, right? Because it is resting on its base, right? And its surface is making an inclination of 45 degree and the resting side 50 degree. Okay, so let's start with the solution. I will be going to give the quick solution for this one. So take a sufficient distance from XY line below and mark one point that draw a line perpendicular to XY line of 40 millimeter length. Then mark the center point, and through center point draw a line of just random length, okay, on which you will be taking 60 millimeter. So of course, measurement from this point to this point and you will get the 60 millimeter, and then finally join it. Okay, join this, you will get the true isosceles triangle. True isosceles triangle means 40 with base and 60 altitude, right? Then take the projection from both the points. Take the projection from both the points vertically, go vertically till it touches to the XY line. Then on this point, you will get the 2 points. Okay. Then take the projection, as I said. Then take the projection from point C. Where it intersects to the XY line, it will give the front view that is in the form of line. Okay. So this is what the front view, you will get it here. Okay. The points are A, B, and A dash, B dash, and C dash, concern point. Then mark any one point here, and through this point, draw a line which is given 45-degree incline here with the surface. So take a 45-degree and take the length of this 45-degree inclined line equal to first stage front view, A dash, B dash to C dash. Same distance you will be taking 45-degree, and then further you will be taking the projections from this point AB, go down, vertical down, then take the projection from A, where it intersects, you will get the point A. Take the projection from B, where it intersects, it will give the point B. Then take the projection from C, okay, and take a vertical projection from this point C, where it intersects, it will give the point C. Okay, and then finally you join this with thick line. So join this with thick line. And you will get the top view completed. Okay. And if you are doing with the auxiliary plane method, this solution, what is given inclined with the VP? Resting side. So resting side is this one. This is nothing but the resting side AB. So extend this AB side further down. Okay. You will be just extending it further. Okay. Through any one point on this, you will be drawing the line at an angle of 50-degree. Okay. At an angle of 50-degree. Through this. Okay. Draw a line at an angle of 50-degree. Any random line. This line is going to be the X1 and Y1 line. Okay. We say it's a X1, Y1 line. Okay. Similar procedure you have to repeat. Take the projection from A. Take it perpendicular to this line. From B, perpendicular to this X1, Y1 line. Through C, perpendicular to X1, Y1 line. Okay. And take the measurements. Find out where is point A dash, B dash. A dash, B dash is on XY line. So obviously you will get the A dash, B dash point on XY line. C point C, it is away from, I will make it with the different color. Okay. Your C point, C dash point is away from XY line by this much distance. So this distance you have to have a measurement in your rounder, and keeping one end at this junction, that touching point of this projection on XY line, and cut it with that distance, and you will get the C dash point from X1, Y1 line. Finally, join these points with straight line. Join it, and you will get the final front view, right? So this way you will get the solution for this. Okay. Similarly, if I will just, if I change the problem statement, keeping all those things remains same, but only instead of resting on H in a front view, and top will become the line view. Okay. Similarly, the procedure you have to repeat and you have to complete the solution for plane resting on vertical plane. Okay. So I already communicated you that few my videos are there on YouTube. I think during your vacation you might have gone through those videos. Okay. If it is so, I think it is fine. If not, even I am going to take few more cases so that there will not be issue. Okay. Then I will be taking to the new case here. Okay. So this is a very, very important stage now. Okay. And you have to understand the very important concept. Okay. So I'll make it 100%. Okay. Okay. Now you have to be very careful in understanding the problem and understanding the new concept. Okay. See, first of all, we will read the problem statement. Okay. A rhombus having major diagonal 70 millimeter and minor diagonal 40 millimeter is resting on HP on its corner of longer diagonal. Okay. Draw the projection of rhombus when its surface is inclined to HP at an angle of 45 degree. And two cases have been explained with the A and the B. If minor diagonal is inclined to VP at an angle of 30 degree. And if major diagonal is inclined to VP at an angle of 30 degree, right? So here, if the minor diagonal is and my major diagonal is okay. So this will discuss in detail now. Okay. First of all, write down the given data. Type of plane, that's a rhombus, 70 millimeter by 40 millimeter in terms of diagonal, resting on HP on corner of major diagonal. So what exactly you have to do? You will be taking the diagonal, longer diagonal corner on left side, not a side or not a minor diagonal corner. Okay. So you will be taking the major diagonal corner on left side and you will be completing this top view. Then complete this front view. Okay. Then it is mentioned that surface is inclined at 45 degree to HP. So through this point, you will be making it 45 degree and completing this front view. Okay. Then taking the projection, you are going to complete the second stage, top view, right? Then what it is given here, if first we'll talk about the first case. If minor diagonal is inclined to VP, okay, which one is the minor diagonal here? I will mark it with the line here. Just leave me. Okay, so this is what the minor diagonal, right? B dash D dash, because in the first stage you'll see this is nothing but the minor diagonal and AC is your major diagonal. Okay, what is given? The minor diagonal is inclined. So what exactly we are going to do? If you are going to solve this problem with the auxiliary plane method, will be extending the minor diagonal, not any side now. Remember, minor diagonal we are extending, marking any one point, and through this point, I will be taking a line at an angle of 30 degree, which is given. Okay. And as usual procedure, I will repeat, taking the projection perpendicular to X1, Y1 line from A1, B1, C1, and D1 point, and taking the constant distances from this second stage front view. And I will complete this. Okay. Now on screen, you might be looking the different parameters happening here, different things which you are not learned up till now. Okay. So we'll start talking about the second case. That is, a major diagonal is inclined to VP at an angle of 30 degree. Okay. So this is what the important thing about which you have to think now. Okay. So we'll talk in detail about this. See, you might be knowing about the major diagonal. See, major diagonal is this one, A to B. Minor diagonal is B to D. B to D is the minor diagonal, this major diagonal. Okay. Anyone from your class, just unmute yourself and just respond me. Anyone, even Sunraj, you can. Okay.
Yes.
If possible, you just keep responding. Okay.
Okay.
So yeah, you just compare the first stage top view and the second stage top view, and you will be looking at the changes happening in terms of length of diagonal. Okay. See. Okay. Yeah. So I will ask about the minor diagonal. Length of minor diagonal, first stage and second stage. Do you find any change in length of this major minor diagonal?
No.
Absolutely no. Okay. So if you already studied the projection of line. Okay. If true length is seen, then no need of alpha or beta angle, right? If the length of line is not remain true, then definitely there will be the alpha and the beta. Okay. So now the question arises as the case we are going to deal with the different case here. Okay. Now tell me the major diagonal AC in first stage and major diagonal AC that is mentioned with the A1 and C1. Is it equal? In terms of length, is it equal? Yes, Sanraj?
No, sir.
No,
No.
sir.
Length, major diagonal AC, which you will find in first stage, that is 70 millimeter.
No, sir.
Are you going to get the same length in second stage when you make it inclined at an angle of 45 degree?
No, sir.
Absolutely right. Means, if this is the case, the way we have done in projection of line, finding alpha and the beta, similar thing you have to do it here, okay? And with beta angle, which you will get later on by following certain construction process, that angle you have to take instead of this 30 degree, which you have been mentioned here, okay? So you have to find out beta now, okay? You all studied projection of line, I repeat, and you are aware with the alpha, beta, when it is needed and when it happens, because when the line is inclined, not parallel to any plane in that case, okay? So how you can do the beta construction? You have to find out the beta. Have understood why we have to you have to find out beta? Because the parameter which is mentioned, that is happening with the apparent length, reduced length. Then that's why we have to find out the beta. If the first case is concerned, as you done with the first case, minor diagonally inclined, and you have to compare whether minor diagonal in first stage and minor diagonal in second stage is changing. No, then you need not find beta. If now the case is major diagonal is given inclined, major diagonal true length and the major diagonal apparent lengths are different. Okay, so specifically here I have mentioned, I will be providing this PDF to you. Okay, so it will find a bit clear. Okay, so you have to go for the beta construction. Okay, so this is what the beta construction which you will see here. Okay, but I will be going to show you with the separately. Okay, so what you can do, draw one line. Okay, then through any point draw a line at an angle of 30 degree, at an angle of 30 degree, right? 30 degree, and this length of line is equal to true length. This length will be equal to true length. Okay, this line is going to be the equal to true length. Okay, so this line and the true, this line I will mention here specifically. This AC and this AC is of equal length. Taking this angle 30 degree, you just see here 30 degree, which I have mentioned here, and this length A to B is nothing but the line equal to AC. Okay, angle is 30 degree. See, this is the length line AC. That measurement, that 70, you have to take it and you have to draw a line at an angle of 30 degree and take that 70 millimeter distance. Okay, so I can say this is a TL. I will say it's a TL. Okay. Okay. So this length is going to be the length TL, right? This length is going to the length TL, right? Okay. Right. So once you will get the true length at this point, next one, draw a line through this, which is going to be the line parallel to previous line, which you have drawn. Okay. So this line is parallel to this one through point C. The similar thing we have done here. Okay. So draw a line parallel to the previous line, this one. Okay. Now you have to take the measurement of apparent length, or we can say the plan length. As far as this case is concerned, we can say the PL. So how much is this thought the true length? We shall see in a first stage, and second stage we're going to give the PL, or we can say the apparent length. Okay. So take a distance from this A point to C point in rounder, and keeping one end at A, same point, cut this line. I will, okay, cut this line with this kind of arc. Where it cuts, you will get the point. Okay, then you can join this line. Sorry, I will make it with the straight line. Okay, join this line with the point which you have got on here. Okay, and then have a measurement of angle. This angle you have to measure, and this angle is going to be the angle beta. Okay, and here, as far as this case is concerned, if beta is going to get 45 degree instead of now 30, it was the 5 distance 30 angle 30. Now you got the beta 45 degree. Okay, means in third stage you are going to utilize beta angle instead of given angle 30 degree. Okay, now the same problem but taking major diagonal inclined. What exactly you have to do here? First of all, extend the major diagonal further instead of extending this diagonal. Okay, because minor diagonal is not given inclined. Okay, so major diagonal is given inclined. So extend this, mark any one point here, and through this point draw a line at an angle of 45 degree. That is nothing but the beta angle. Okay, and draw a line 45 degree. This line is going to be the x1 y1 line. Okay, which is on the extension of this. Okay, extension of this major diagonal. Okay, and repeat the procedure for as usual, taking the projection from A, go with A perpendicular to x1 y1 line, go with B, I think it will be coming on the same, take the projection through C, take the projection from D, and have a measurement of concerned point A dash. A dash is on XY line itself, so A dash point will be here. B dash D dash, this distance from A, B dash D dash is this one. You take this much distance in compass, and through B and D, B extension यहाँ पर है, so B and D, take the distance, cut it here, you will get the point. Take the distance, same distance through D, extension of D from B, this point, X1 line, XY line is this one, cut it, it will get the, give the D point here. Okay. Similarly, take the distance XY from XY line, this distance, take distance, keep compass at this end, extension, cutting, crossing the X1, Y1 line, touching. Okay. Through that line, you take that distance and cut this line. Where it cuts, you will get the point C. And finally, join all those obtained points in a sequence, A to B, B to C, or C to D, or any way you can just have to join it. Okay. So you will get the answer with inclusion of beta, finding beta. So you have to first of all look at the problem statement, look at the first and second stage, compare it, then decide whether you have to find out beta or not. If required, you have to find out. If not, you can continue with the as usual angle. Okay. So Sunraj, yeah, you can stop recording. Yes, Sunraj.